In early October, something remarkable happened that most of the world missed. As 3I Atlas passed within visual range of the Mars Reconnaissance Orbiter, NASA quietly redirected its most powerful space-based camera, HiRISE, away from the Martian surface and toward a fast-moving object hurtling through the solar system. That object was 3I Atlas, the third interstellar body ever confirmed, and the only one to exhibit behaviour that defies both trajectory logic and physics. Earth's telescopes had been capturing hazy data for weeks. Most of what we saw from the ground was distorted by our atmosphere, revealing only a long, bright tail and the faint suggestion of forward motion. But the HiRISE camera had a clearer view. Positioned millions of kilometres away, and with no atmospheric interference, it was able to capture a side profile of 3I Atlas that no other instrument could match. What it saw was not just unusual, it was paradigm-breaking. Instead of a comet-like jet trailing behind, the spacecraft captured a highly focused jet emerging from the side of the object, locked perpendicular to the sun's direction. This wasn't a blurred line or a photonic artifact. It was a structured emission, a defined sharp beam extending thousands of miles across space. The significance of that angle cannot be overstated. In natural systems, jets follow solar energy. They react to heat, wind, and light pressure. But this one ignored those rules. What Mars saw shattered every model. It wasn't the brightness that caught scientists' attention, it was the geometry. And as the data was processed in silence, one question began to echo in research labs across 3 continents. Was this jet a reaction to heat, or a controlled release? In astrophysics, orientation means everything. Whether it's a comet's tail, a planet's ring system, or the arc of a coronal mass ejection, the direction of force tells us what's causing the behaviour. In the case of 3I Atlas, that directional fingerprint is deeply disturbing. The HiRISE camera didn't just show a beam, it showed where that beam was pointing, exactly 90 degrees from the sun. A perfect perpendicular, and that makes no sense in any known natural model. When a comet approaches the sun, solar heating causes ice beneath the surface to sublimate. That transformation creates jets, visible streams of gas and dust that shoot outward, typically pointed toward or away from the solar body. The resulting tail always aligns with the direction of incoming solar radiation, or the solar wind. That's why tails usually trail behind the comet's motion, or extend directly away from the sun. But this wasn't that. The jet on 3I Atlas wasn't trailing or bending. It wasn't arcing like we've seen on Hale-Bopp or 67P. Instead, it formed a straight, rigid line stretching across space like a focused column, and it maintained this orientation regardless of the object's direction of travel or solar position. This suggests one of 2 things. Either there's a previously unknown mechanism in cometary physics, something that overrides all solar effects and generates energy orthogonal to the sun, or the force behind this jet is not natural at all. Worse, the structure is so stable that it defies the chaotic behaviour we associate with surface outgassing. That points toward control, not randomness. A system that maintains shape, angle, and pressure across interstellar space is not drifting, it's choosing. For most celestial objects, rotation is a natural byproduct of formation, a spin set in motion by the conservation of angular momentum during birth. That spin is usually irregular, subject to wobble, mass distribution, and external forces. But with 3I Atlas, the rotation isn't chaotic, it's clockwork. Astronomers tracking its brightness over time began noticing a repeating pulse, a dimming and brightening cycle that returned precisely every 16 hours. This pattern, confirmed through multiple light curve analyses, pointed to a regular rotation period. That alone isn't extraordinary. Many asteroids and comets rotate. But what's unique here is what the rotation doesn't do. A spinning body with outgassing jets typically creates dynamic, moving tails. As the surface rotates into sunlight, new ice pockets heat up, spewing gas in sweeping arcs. The result is spiral-shaped trails or curved emission cones, something we've documented in objects like Comet 9P Tempel and 67P Churyumov-Gerasimenko. But 3I Atlas is different. Despite its 16-hour rotation, the perpendicular jet remains fixed, locked in place without the telltale swirl of spin-induced tail motion. That can't happen unless either the rotation is perfectly aligned with the jet axis, or More disturbingly, the jet mechanism is independent of surface heating. It means the object could be compensating for its own spin. Imagine a device in deep space with internal gyroscopic stabilizers, capable of maintaining orientation even as it turns. That's the kind of behavior engineers expect from spacecraft, not icy debris. And yet, every frame from Mars and every observation from Earth suggest one conclusion: the jet is steady while the body spins. We're no longer looking at a tumbling rock. We're witnessing a system, rotating but regulated. The word columnated is rarely used in discussions of natural space phenomena. It describes a stream or beam that retains its shape over long distances without dispersing, something we typically associate with technology: lasers, ion propulsion systems, even engineered exhaust nozzles. Nature, by contrast, is messy. It doesn't create straight lines. But 3i Atlas may have just changed that. When the HiRISE camera returned its images from orbit around Mars, what stood out most wasn't the brightness or length of the jet. It was the geometry. The beam didn't widen. It didn't diffuse. It didn't arc. It remained razor straight, like a thread stretched taut across space. A structure, not a plume. This isn't how comets behave. Even tightly focused natural jets from surface vents eventually bloom outward due to solar wind, centrifugal force, or particle scattering. But not here. This raises a serious question. How is the jet being maintained? Some researchers propose that the beam might be the result of an internal pressure system, one that regulates thrust in a directed, narrow cone. This would imply that 3i Atlas contains compartments or channels beneath its surface capable of focusing an emission along a fixed vector. That sort of behaviour sounds less like geology and more like propulsion. Now consider this. In man-made spacecraft, columnated emissions are the norm. They're efficient, controlled, predictable. If 3i Atlas is maintaining a beam across thousands of kilometres in a perfect line, we have to ask, where is the energy coming from? What's controlling the pressure? And most importantly, or is this beam even an outgassing jet, or something else entirely? If this is engineered behaviour, then we are not just observing an object, we're watching something operate. Comet jets, when observed in motion, often reveal the same story. A nucleus spins, sunlight strikes, and as trapped gases heat up, they burst forth in elegant spirals. It's one of the most visually striking phenomena in observational astronomy. These spirals are caused by rotational motion. As the comet turns, the jet's direction changes, leaving a corkscrew trail behind it in space. This pattern is so common that its absence now serves as a red flag. With 3i Atlas, no spiral appeared. Not in the first images, not in the follow-ups, not even after weeks of monitored spin. The 16-hour rotation, confirmed through light variation data, should have produced a curved, dynamic trail if the jet were fixed to a natural surface vent. Instead, we saw a linear structure, unwavering and directionally locked. That's not a pattern, that's a program. In every known case where cometary jets are influenced by spin, curvature appears. Hubble captured them, Rosetta proved them. Even distant telescopes on Earth picked up the telltale arcs of rotating jets in past cometary events. But 3i Atlas stands alone, a jet that defies the rotational effects of its own body. Some experts have speculated that the jet might be adjusting in real time, actively compensating for rotation to maintain its alignment. If so, that suggests internal sensors, feedback loops, systems that detect orientation and adjust output accordingly. Again, this is spacecraft logic, not comet logic. And here lies the core tension. If 3i Atlas was spinning freely, nature would have written that rotation into the trail. But nature has been overridden. No curves, no swirls, just a straight, silent thread, like the kind only intelligent systems know how to draw. When light from a distant object travels toward Earth, we learn more than just its brightness. Subtle fluctuations in its intensity, what we call a light curve, can tell us about its spin, shape, and surface texture. Over time, these fluctuations form a repeating signature, almost like a fingerprint. And when scientists analysed the light curve of 3i Atlas, they weren't met with randomness or chaos. They saw rhythm. The 16-hour spin cycle wasn't the only anomaly. It was how the light dimmed and brightened, in precise, patterned intervals, that began to raise eyebrows. Instead of gradual fades or jagged peaks like those seen in uneven comets or asteroids, 3i Atlas displayed sharp transitions and flat plateaus. These features suggest that the object's surface isn't naturally jagged or spherical, but faceted. In simpler terms, it reflects like a structured object, like something built with angles. Researchers began comparing these plateaus to those seen in tumbling satellites or spinning space debris, objects with large flat panels or engineered surfaces. The comparison was uncomfortable but hard to ignore. One particular set of readings revealed repeating dips that could only be explained if the object had alternating bright and dark faces, not unlike solar panels rotating in and out of view. There's also the timing. The moments of greatest reflectivity aligned with periods where the perpendicular jet was most visible. That would only occur if the jet's emission point and the highly reflective face were part of the same mechanical region. Two systems synchronized, and that leads us to a chilling thought. 3i Atlas isn't just spinning, it's displaying order, patterns, systems. And in the universe, those don't occur by chance. They are signs, not of chaos, but of intent.